Hi, I'm Gajendran here. Okay, today we'll be talking about the process for production of styrene. Alright, so the main objective of this process is to develop styrene as final product from ethyl benzene, as well as to obtain a final product purity of minimum of 99.7 weight percentage, taking into consideration of the economic and environmental aspect. Lastly, the objective is to have a production capacity of 250,000 ton per annum. So looking into the current market needs of the product, styrene has many major markets such as polystyrene and etc. The main application of styrene can be found especially in the petrochemical industry. Styrene is in high demand in the current market due to its ability of making a variety of products, delivering many benefits which are valued by customers worldwide. Styrene has a wide range of uses as it's strong and durable.
Hi, I'm Mahendran. I will talk about methodology for this process. Firstly, I'll explain about identification of chemical components. Based on the reaction we have done, dehydrogenation of ethyl benzene produces styrene, hydrocarbon, and the decomposition of which is also known as the side reaction causes the formation of water, toluene, and benzene. Next, I'll explain about the selection of fluid package. In class, we have learned about using many type of fluid package, including Peng-Robinson, SRK, and many more. For this process, myself and my groupmate have decided to use SRK, which is Swift Redlich-Kwong fluid package, rather than using Peng-Robinson, because the temperature range is more than negative 143 degrees Celsius and pressure range is less than 5000 kilopascal. Peng-Robinson can't really work with these parameters, but SRK can work efficiently using these parameters. Another factor of using SRK fluid package is because of hydrocarbon and hydrocarbon burning. SRK can work much more efficiently compared to Peng-Robinson in this concept. Next, I will explain about setting up the reaction. Firstly, PFR reactor is chosen instead of using equilibrium reactor and also conversion reactor. This is because both of the equilibrium and conversion reactor can't really work in kinetic reaction. As you can see, the diagram is a screenshot from the Unisim software. The only A and E values are changing throughout the process for reaction 1, for reaction 2, and also for reaction 3. As you can see, first reaction is reversible and it has both forward and backward reaction values, whereas the second and third reaction are only non-reversible and it only can form forward reaction. The pre-exponential factor and activation energy values obtained from book title Analysis, Synthesis, Design and Chemical Process, which is available in our UCSI library. The values in this book used and adjusted by using trial and error method, and also advices from our seniors and also other lecturers. Next, I will explain about basis of this reaction. Basis of the reaction is converted from molar concentration to partial pressure due to the involvement of partial pressure in the kinetic equation. This is the reason of changing molar concentration to partial pressure, because when we use molar concentration, there will be a lot of complication in Unisim and there's a lot of conversion in the Unisim software. To ease and to fasten the process, we just change the molar concentration to partial pressure, and also it is more likely to react with linked with kinetic equation. Lastly, I'll explain about process development. Some of the issues faced by using the simulation is of selecting the type of reactor. In Unisim, we know that there is no packed bed reactor, but in this process there are many use of packed bed reactor. So we have decided that to replace packed bed reactor in Unisim software with plug flow reactor, which is more suitable for kinetic reaction, and it was strongly chosen for the process. One of the other main aim for the process was to conserve and utilize the waste product by recycling. As an engineer, we must reduce the wastage and conserve the energy so that the product will be more successful. Lastly, I'm showing you the complete process from the Unisim software. This is a screenshot, exact screenshot from Unisim software. So as you can see.
So my name is Sudarshan. Today I'll be talking about results. So starting from the stream condition, the feed stream. So the properties of the feed stream, as you can see, the temperature is set at 16 degrees Celsius. The pressure is at 0.2 bar and the molar flow is at 935 kg per hour. Going down, the recycle stream, we have a temperature of 125.3 degrees Celsius, pressure of 1 bar, a molar flow of 118.5 kg per hour. So the results we obtained from the plug flow reactor is as stated. From the reactor 1, we have a total volume of 10053.096 meter cube. The length of the reactor is 20 meter, diameter of a 4 meter, and number of tubes of 40, with a wall thickness of 0.005 meter. In the tube packing section, we have a void fraction of 0.9, a void volume of 9047.787 meter cube. Looking down at the reactor 2, we have a tube dimension of a total volume of 628.319 meter cube, a length of 10 meter, diameter of 2 meter, and number of tubes of 20. The wall thickness is also at 0.005 meter. And the tube packing part of this reactor. So coming down to the superheated steam's property table, we have a vapor phase fraction of 1, temperature at 800 degrees Celsius, and a pressure of 1.7 bar. Coming down to the distillation feed stream, we have a temperature at 10 degrees Celsius, pressure recorded at 1.52 bar, and a molar flow of 1060 kg per hour. So at the final product stream, we have a temperature recorded to be 141.4 degrees Celsius, pressure of 0.9 bar, and a molar flow of 277.4 kg per hour. At the final product's composition, we have ethyl benzene at 0.003058 and styrene at 0.9996942, adding up to a total of 1 molar flow rate mass fraction. The total energy usage and waste generated. The vapor waste from V100 separator. Methane's mass flow is at 29.146, toluene is at 1838, benzene is at 22,183. So totaling up it to 58,481 and 54 kilogram per hour. So looking at the liquid waste from the V100 separator, the total from the liquid waste V100 separator is 1531196.42 kg per hour. Waste generated could be classified as 3 types, which is vapor waste from separator, liquid waste from separator, and top product form. T101 distillation column. Main waste component is ethylene, methane, hydrogen, and water, where hydrogen could be reused for combustion process in the system, which would reduce the cost of production. Total mass flow of waste generated is calculated as stated. The total waste flow rate generated per hour is equal to the total A12 mass flow rate plus total A7 mass flow rate and the total A9 mass flow rate, which comes to a sum of 1601659.232 kg per hour.
My name is Privina and I'll be doing the discussion part. So the first one will be ethyl benzene. Ethyl benzene is the most produced vapor in the system. Ethyl benzene is capable of producing impact based on the short-term and long-term exposure, which causes health hazard and environmental hazard. So as for the short-term exposure, there's eye and throat irritation and also dizziness. As for the long-term exposure, it causes irreversible damage to the inner ear and cancer-causing agent. As for environmental effects, ethyl benzene is the member of BTAX family, which circulates in the atmosphere, although some of it settles in the soil, but mostly causes pollution by circulating in the surrounding air. The second one would be hydrogen. Hydrogen is classified as a flammable substance with aggressive features in the presence of air. Hydrogen has a tendency to cause explosion. The health effects of hydrogens are headaches, unconsciousness, nausea, and vomiting. As for the environmental effects, the emission of hydrogen disrupts the methane contained in the atmosphere. Moreover, it causes greenhouse effect and global warming. As for the third one, benzene. Benzene is a volatile which evaporates easily to the surrounding. Benzene is also classified as a carcinogenic compound, which causes decrease the immunity level of the human immune system. For red blood cell production, lesser red blood cell will produce in the bone marrow, thus affect the human health. For benzene have short and long-term effects. As for short-term effect, is drowsiness, dizziness and headaches. For long-term effects, it causes anemia, leukemia and cancer. As for the environmental effects, benzene affects as air pollution in the ground level when the concentration increases. This condition allows the benzene to be absorbed to the soil and groundwater. For toluene, toluene is a highly flammable and the substance is exothermic causing component used for combustion. It affects the lungs when the vapor enters the body when breathing. This is capable of causing memory loss. As for the environmental effects of toluene, toluene is a water pollutant which may affect aquatic life when the concentration increases. The component is a volatile which is easy to evaporate. As for sensitivity studies, the purity of the product increases as the number of stages in the column increases, where the desired purity is obtained at 50 stages, but the purity is as low as the stages decreases. The top of the product of the second distillation column is required to be in a liquid form. If there is any vapor content, it will affect and the desired purity and production. So this figure here is showing the steam inlet, mixer and the plug flow reactor. The reactor is the most important equipment of the petrochemical industry, as it is in this industry that the reaction takes place and the product is formed from the feed. The feed is ethyl benzene and the desired product is styrene.
In conclusion, the objective that has been mentioned has been achieved. So styrene is the precursor for polystyrene, which is utilized as a part of plastic defensive coatings and synthetic intermediates. The request for styrene is relatively high. So the most widely recognized strategy for styrene creation is reactant dehydrogenation. So along this line, the group continue with the techniques. So consequently, the group will trusted styrene would give a decent stage to a high benefit intergroup. In addition, the development of the plant give opening for work and increment the economy for Malaysia. So the production of styrene from ethyl benzene through the dehydrogenation process was successfully performed. Scale simulation of styrene production produces a number of waste. So this waste includes benzene, methane and ethylene. This waste must be treated before being vented out into the environment to avoid any environmental problems. So however, for production plant of this magnitude, the amount of waste from the plant is relatively low compared to the production capacity. So this would suggest the production plant is efficiently simulated in unison. So lastly, economic analysis where of the production plant shows that the production plant is highly profitable. So the results of the economic analysis further suggests that the simulation of the product plant of styrene is efficiently simulated. So therefore, it is safe to say that the objective stated in the introduction is achieved.